Right, so yesterday we learned solving trinomials where the a was 1. We just had a factor of, we had a coefficient of 1 in front of x squared, but this time let's learn how to find factor trinomials if it's not 1, if it's greater than. So this is probably, I don't know, it used to be pretty hard, but this is a nice method. I call it the case of method, and I literally tell you step by step what to do. So in your homework, you refer to this, and it literally goes step by step. All the examples we're going to do, I'm going to go step by step. So first, let's factor 2x squared plus 11x plus 12. All right, so right away you would be like, oh, I know how to do this. It's definitely going to be, maybe like 2x plus a number, x plus a number. Trying to think, because not only does it have to multiply to 12, add to 11, when I FOIL it out, right, the inner and the outer, like that 2 in front of x squared, it's hard to figure out what to put there. So there's this nice method that will walk us through how to deal with this. So first, you multiply the coefficient of x squared to the constant term. So you take 2 and I'll multiply it to 12, right, and I get 24. Now, step 2, rewrite the original problem and remove the coefficient of x squared, replacing it with the term found in step 1. Remove the coefficient in front of x squared, and I rewrite my c, which is going to be 24. Step 3, factor into binomials. Okay, so let's think. What multiplies to 24 but adds to 11? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Definitely 3 and 8. That multiplies to 24 and it adds to 11. So I factor the binomials. All right, we're looking for two numbers whose product is 24, sum is 11, so we found it was 3 and 8.
What about product is the end?
The sum is the middle and the product is the end. So it adds to the middle one and it multiplies to the end. So what? Step 4. So now what we want to do is put in the original coefficient in front of x. So original coefficient was 2. So I'm going to go through and I'll put a 2 in front of each of these x's. I'll put a 2 in front of each of these x's. That way it's 2x plus 8 and 2x plus 3. So now we're like going back and being like, wait, this actually wasn't x squared plus 11 plus 24. Right? We're trying to now take into account that we had a coefficient of 2 at first. All right, so I rewrote with the original coefficients of my x squared. And then reduce one or both sides of the binomial so they have no common factors. So notice that the 2x plus 8, both 2x and 8 have a factor of 2 in it. So if I divide each of these by 2, I will get x plus 4. And this turns out to be the binomial, the actual solution. Okay, so if you're like, wow, what the heck? We have 4 examples to go through where we're just going to go through these steps over and over again. So, because I had my other thing of 2x plus 3 from before when I inserted back in my 2 in front of the x's in step 4. No, because 2 and 3 have no common factor. 2 and 8 have a common factor of 2. Okay, and just to keep in mind, what is a prime polynomial? A prime polynomial is a polynomial that cannot be written as the product of 2 polynomials with integral coefficients. AKA, if I can't write it as x plus or minus an integer, it's going to be prime. I don't want to have it x plus 1.5. I don't want there to be decimals. Right? I want the things that I'm plugging in, x plus 1, x plus negative 50, whatever. I want those to be integers. I don't want to say x plus 3 halves. Like, no, they have to be integers. If they're not integers, it'll be prime. So keep that in mind. Let's factor each trinomial if possible. If the trinomial cannot be factored using integers, write prime. So we're going to go through each step. Notice I have a coefficient in front of x squared that is not 1. So step 1 is going to be multiply my constant term by my a, my coefficient. What is 5 times 10? 50. So I'm going to rewrite as x squared plus 27x plus 50. This is step 2. If you look up above, step 2 says rewrite the original problem and remove the coefficient of x squared, replacing the constant term with the result in step 1. Okay, cool. Write it without the coefficient a, write it with the new c we found. Step 3, factor into binomials. So I need to factor this out. I'm looking for what is going to add to 27 and multiply to 50. What adds to 27 and multiplies to 50? 25 and 2, right? If you have 2 quarters, 2 times 25 is 50. And if you add 25 and 2, you get 27. So I'm going to write it as x plus 2 and x plus 25. So this is my step 3, factor into binomials. We were looking for 2 numbers whose product was 50 and whose sum is 27. Step 4, now insert the original coefficient of x squared into both binomials. So I have to insert 5 in front of both of my x's. And step 5, reduce one or both sides binomials so they have no common factors. Can I reduce one of my factors? Yes. Notice this one, both can be reduced by a factor of 5. They have 5 in common. So it turns out factoring is going to be 5x plus 2 times x plus 5. And if I FOIL this back out, I will get what I started with.
And that's how you end it.
That's it. Done. Check.
Is there another way to do this?
Yes.
Does it matter which one goes first?
No.
Wait, what's the other one?
I mean, you can Google. There's like 5 different ways to do this. Yes, by far. This is not the way that was taught to me when I was in Algebra 2, but this is significantly easier. Yeah.
For B though, like where it was 50, you don't know what to call it. It's a odd number you can't multiply with.
And B?
But
Yeah.
You take 5 times 6.
Wait, multiply.
multiply
5 times 6.
So in B?
Yeah.
All right. So first step, take the coefficient and multiply it to your C. So 5 times 6 is 30. Okay, awesome. Step 2, rewrite the original problem, remove the coefficient in front of x squared, and use our new number for our C, right? We're using the A times C, the 5 times 6. Does this answer your question? No.
Yeah.
Yeah? Okay, step 3, factor into binomials. So I want to know what is going to add to 13 but multiply to 30. 10 and 3, right? If you add 10 and 3, it's 13. Multiply is 30. So how did you come up with that number so fast, Dylan? What'd you do? Yeah. So think of the factors of 30, right? 5 and 6 multiply to 30, but they only add to 11. 3 and 10 would add to 13. 2 and 15 would add to 17. So you have to think of the factors and then add them. Okay, so I'm going to write this as x plus 3 and x plus 10. Okay, that was step 3, factor into binomials. Now we're going to go back and insert the coefficient back into my binomials. That's step 4. So 5x plus 3, 5x plus 10, and you already know what's coming with step 5 is exactly the second one. Both of these are divisible by 5, so I can rewrite my solution as 5x plus 3 and x plus 2. How do we feel about this? We okay? I think so.
So many steps.
It is 5. Practice, just takes practice. Okay, let's try C. Do you need to leave this up here a little longer? No. Okay, cool. Try out C. So, first step, take your coefficient, multiply it to the C. Step 2, rewrite it. So I have t squared minus 11t plus 14.
Something has to equal, the sum of something has to be -11.
Yep, so it has to add to -11. Multiply to 14. So let's come up with the factors of 14. Right, factors of 14. I could have -1 and 14, 1 and -14, 2 and -7, or 7 and -2. Right, I need them to multiply to 14, add to -11. Okay, so this turns into 13. This is -13. This is -5, and this is 5. None of them are adding to what it should be. There's no more factors to write, right? There's no more factors. Exactly, prime. It's prime. I cannot write them as a product of two binomials. I can't. That's it. There's nothing. So if I was asking you to solve, you would have to plug into the quadratic formula. Like this would be one you'd have to plug into the quadratic formula and you would get decimal answers or something.
So wait, so this just, the answer is just prime because there can't be like nothing, the sum of nothing.
There's no two integers where I can't write it as x plus a number and x plus a number. Like I can't write it as two integers. I could say like, oh, 2x plus 1.57 or something, right? The roots are not going to be integers. All right, and if you're done, try out D. Before I move on, try D. If you're not, are you done with D? Okay. Are you done with D, Ashton?
Yes.
So I come over to your paper, it's going to be written on there?
Yes.
False, don't lie to me. I see your notes are not out. Okay. So, step 1. Take the coefficient, multiply it by your constant. Rewrite. Shh. Rewrite with your new C.
What if you can like,
We're looking for what adds to 14 and multiplies to 48.
8 and 6.
8 and 6. You said you were done. And then you just had a burst of inspiration.
I did do it.
Okay. Perfect. 8 and 6. Perfect. Okay, cool. I'm glad. 8 and 6. I don't. My tip is broken. Shoot. Okay. 6 and 8. Okay. Step 1 done. Okay. Whatever. Step 3 done. Step 4. Insert the original coefficients.
2.
2p plus 6 and 2p plus 8.
2 plus 3.
and then p plus 3 and p plus 4.
Exactly. They both can be reduced. So I have p plus 3, p plus 4. Wonderful. Because the tricky is, guess what? We could have factored out the 2 at the beginning and had the 2 on the outside. Wonderful. Right, because I could have rewritten this equation as p squared plus 7p plus 12. All I did was multiply this whole thing by 2. This gives me the same roots. All right. Let's see.
What did you do for that one?
Which one? This one? It's more practice. It's more the same thing.
Oh, but they're not. Those ones are equal to 0.
Oh, because it says solve each equation? Yeah, once I factor it, I said each of the factors equal to 0.
You
Okay, let's do this one.
just do it.
Huh?
You just do the same one.
Yeah, but then when you get the factors at the end, you take each one of them, equal them 0. Solve for what p would be.
Oh, like what we did.
Yeah, like what we did with the 0 product property. You say you don't like it? I believe you said the exact same thing yesterday. Perfect. All right. Do we have enough time to write down? Do you want me to go back? We okay? Yeah? Okay. All right, you know what? Let's try this one. We'll do this as an example, and then we'll keep going. All right, take the
You just leave it.
leave it there for the end. Leave it there for the end. So this is pretty much the same thing. Rewrite.
You said you multiplied the whole thing, but aren't you just multiplying the 6?
The last example, we did multiply the whole thing by 2. That's what I mean. Hold on. D. Right here, that whole thing was multiplied by 2. You see how I had 2 outside of p squared plus 7p plus 12? Because, right, I could factor out a 2 from everywhere.
That makes sense.
Yeah. Okay. So I want to know what is going to add to 11, multiply to 18, 9 and 2. X plus 9, x plus 2. What? You're one step ahead of me. Equals 0. Then I'm going to rewrite this in terms, put my original coefficient back in front of x. Oh my gosh, I see I have a common factor. So I have x plus 3 and 3x plus 2. So the difference between what we were doing before and what we're about to do now is after we factored, we want to solve. We know how to solve. You set each of our factors equal to 0. So I believe that's, so this finds the solutions. It finds the x-intercepts.
Oh, yeah, I'm just saying, ask you,
Like in real life, are you asking?
It's math.
You're not, you're just mathing.
you're gonna find that.
Math helps your brain learn how to learn.
Yeah.
That's one answer. Critically thinking, learning how to be tenacious, learning how to get through difficult things.
And also, I come with all these
Math
like,
is
theoretical
gonna be
things that
Okay.
you can never prove, but you can prove. them.
Okay, let's keep going. Cool. So I set each one of these factors equal to 0. So I see x equals negative 3. And I set 3x plus 2 equal to 0. Yep. Yeah, that's the difference. We just go through and we just solve for what it is. Okay, so I'll leave B if you want to like come in bonus, work on it with me. Cool. Let's do example 7a. Factor and solve this out. What? It's not because the coefficient in front of x squared is 1. So I want you to try 7a. Factor 7a. No. It's not. 5 and 14. Both of them have to be negative though.
Negative 5, negative 13.
What? Because a negative times a negative is positive. And then they have to add to negative. So both numbers have to be negative for B. They're talking about B. I want you to try example 7a.
Oh, okay. Is this okay?
They asked me a question about B. Okay. We're doing example 7a. I want you to factor and solve. So we know how to factor x as a coefficient of 1. So I'm wanting to know what's going to add to 8, multiply to 16. 4 and 4. 4 and 4 adds to 8, multiplies to 16. So I know it's 4 and 4, so I write x plus 4, x plus 4 equals 0. So I set each of these equal to 0. I get x equals -4. Oh my gosh, guess what? The other side, I get the same thing. This is an example of a perfect square trinomial. A perfect square trinomial only has one solution. It's literally the same factor squared. It's multiplied by itself. I could rewrite this as x plus 4 squared because there's two of them. I can literally say it's squared. Okay, thought that was interesting. Do I want to do these right now? Hold on. Factor solve.
Still have 5 more pages.
Yeah, I'm fully aware. I know. This is. Why?
Because there's only like 13.
I know. Alright, I want you to try example 7C.
Oh, I know this one. I do it now. Yeah, I'll do it.
That's why I have 2 days of review for the chapter test, because I thought we might bleed into each other. Alright, are we done with C?
Oh, there's one.
I'm still, oh, okay.
So small.
Do we know what a difference of squares is? Jogging your memory, I'm trying. A difference of squares. Difference is subtraction. Squares are things that are squared. Notice I have x squared and I have 36. So what times itself is 36? 6. What times itself is x squared?
Perfect square.
So the way you would write it is x plus 6 and x minus 6. So you see x is equal to -6 and 6. So this is why if I would have just did x squared equals 36, square root both sides, you'd get x equals plus or minus 6.
You can write that.
Well, I get the same answers.
I didn't drop that.
Didn't we do
I
one
didn't drop
earlier,
it.
which was
No.
similar to this?
Yeah.
But we didn't do it that way, it's x and then parentheses x minus, like, the number and then equals to 0. and then
Can I just look what you're pointing at? Well, but notice that this has an x and an x
Oh, and an x.
There's no x here. Alright, so you should have your phone
Either way.
noise on. What?
Either way works.
Both, this gives you the same answers.
So,
So I'm wanting you to, hopefully, I'm trying to like help you remember what a difference of squares is. Because it's just, x plus a number, x minus a number.
So we can't do it the other way.
This way, no.
keep the square root.
Did I give you a problem like this on your homework? I don't think I did.
I don't know.
I'm pretty sure I did not. Okay. Let's try D. Let's try D. This would be a good example. So, how do I factor and solve? I need to factor it. What should I do? Go through the order. First, see if there's a greatest common factor. Do I have a common factor? Yeah, okay, so that's what I'm gonna do. If I didn't, I would have to go through and check. Take away 9x, so I have 9x squared. 9x minus 1. So these problems are thrown on here to do semi-review of what we've already done.
How do you put them?
Because what's 9x divided by 9x? Right, negative 9x divided by 9x is -1.
So the 9x is from the 81.
So I'm dividing 9x on both of these because I'm pulling it out because I'm factoring it. So I set 9x equal to 0. Divide by 9 on both sides. I get x equals 0. I set 9x minus 1 equal to 0. Exactly. Halloween is over. We can't be spooked out by fractions. X is 1/9. We're good. do,
So this, we just totally forget the whole, like,
so we're going through the hierarchy. When it says factor and solve, I wasn't being specific. So we try, like there's an order to it. First we see, is there a greatest common factor? In A and in C, there was no common factor. Then we see, is it actually a perfect square trinomial like A, where it's the same factor twice? Is it a difference of squares, where it's literally x plus a number times x minus a number like C? Can we factor it like normal, like we have been? For example, 8a, we're just gonna factor like we did. Or, shoot, the first thing you always should try is factoring out the greatest common factor. Like pulling out the greatest common factor. You always try that first. And if that doesn't work, what?
Is that what we did?
Yeah, that was the very first thing we did with the first question. Pull out the greatest common factor. It's the first quick pull we did. So you always try greatest common factor first. Then see, is it a perfect square trinomial or a perfect square? Then see, can you factor it? Then you'll go to the quadratic formula. That's your order you have to go through every time. Okay.
Are you gonna give us the quadratic formula and you have to memorize it again?
I will cover that when we go over the section with quadratic formula. Okay. All right, let's try B. So, can I pull out a greatest common factor? No, there's no common factor.
Do the thing.
4x.
Right? Especially because I have a trinomial and, as they're saying, we have a coefficient in front of x squared. We're going to have to do factoring.
36. 4 times 3.
What? We are going straight to factoring. There's no common factor, though. There's no greatest common factor to pull out. Yeah.
Negative.
My pen is broken, and I'm trying to write as nicely as possible.
So it's x minus 6 and x minus 6, right?
Yes.
So 36.
What's the next thing we need to do? Put back in the coefficient. Ashton, you shouldn't have your phone. Phones are in the red holder.
I'm not using it.
I didn't ask about that.
Wow.
Didn't ask about that. Literally on the board, on syllabus, verbally, multiple times today I've said put your phone away. We put it in the red holder. That is the policy. So I put in 4x minus 6, and then I have 4x minus 6.
I'm gonna lose it. We're gonna lock it in the room and then I'm gonna cry something.
So this is 2x minus 3 times 2x minus 3. It's the same factor. This is a,
Why do you divide by 2, not 4?
because 6 is not divisible by 4. The greatest common factor they have in common is 2. Yep. And then since we're trying to solve, we have to set each of these equal to 0. Well, guess what? We're going to get the same answer for both of them because it's the same factor. X is equal to 3 over 2. That's the one x-intercept we have. That's the one place where it crosses the x-axis. The one solution, the 1, 0, the one root that we have. Because it's the same thing. Turns out B is secretly a perfect square trinomial. X is equal to 3 over 2. What? What do you mean?
Divide.
So I followed the rules of coefficients other than 1. Yep.
And then it's just
So the 1, 2, 3, 4, 5 I circled are the order. It's the steps for solving, for factoring with coefficients of A other than 1.
so then you put both of those equal to-
There's only one solution, right? And it's the same factor, so I'm only going to do it once. Okay. Doo-doo-doo. So let's do A and B. Go ahead, factor and solve example A and B. Is there a greatest common factor? No. Is A a perfect square trinomial? It doesn't seem like we're going to get the same number. So we're just going to try to factor. Just try to factor like normal. So what adds to negative 2 multiplies negative 15.
Wait, I thought we have to do
That's just negative 15 then. Because that's only for coefficients other than 1. Yeah. Adds to negative 2, multiplies to negative 15. Yeah, negative 5 plus 3 is negative 2. Negative 5 times 3 is negative 15. Cool. So that works out. So I'll have x minus 5 and x plus 3 equals 0. And then to solve, you set each factor equal to 0. All right, try out B. Give it a shot before we go over it together. Try out B, give it a shot before we go over it together. So the first thing I need to do is move 11x to the other side. Move 11x to the other side. So I have x squared minus 11x plus 30 equals 0. So I'm looking for what adds to negative 11 and multiplies to 30. What do you think it is?
Negative 6, negative 5.
Negative 6, negative 5. Because when you add to a negative but multiply to a positive, both of them have to be negative. X minus 5, x minus 6. And then to set each of those equal to 0.
I didn't see that.
X equals 5 and x equals 6.
Woo! We did it! You did the
Awesome.
answer.